Hello learners, welcome again on tutorial of designing an MZI on KLayout. My name is Subhash Arya. So let us begin. I have opened this KLayout version 0.30.0. Go to File for new layout. Give the name of the top cell, top Subhash Arya underscore MZI variant. So this is the top cell and we have opened this canvas. Now I wanted to draw the floor plan. This is the first step. So I select here layer, go to box and draw a box of size 605 micrometer by 410 micrometer. Select this leftmost corner is at 00, then 605 micrometer by 410 micrometer size of this floor plan. This is the area of design. Then I wanted to open the custom by branch from the location. So this is desktop. I go to this variant and from here Y branch .gds file is available in the another panel. Now I wanted to copy this Y custom Y branch and paste into this our top cell. Seems it is not pasted. Again I copy, say copy and paste. Now this is available in our top cell and show it as the top. Now you can see in the floor plan Y branch is not visible even if we go to full hierarchy. So in order to create Y branch in our floor plan, we can create an instance, go to instance, local library and Y branch, then say yes, and this, and put our Y branch at a particular appropriate location, press escape. Since it is not visible, only this box is there. So go to display full hierarchy. Now you can see our custom Y branch is available in the floor plan. Next step, we go to libraries, EBeam components. From there, I select grating couplers in order to create an MZI. So this is the grating coupler which I am going to use. So for that purpose, I go to instance, select library. In this, I'm going to select EBeam grating coupler TE mode, optimize at 1550. And for design purpose, I'm going to use 3 grating coupler in 3 rows, 1 column at the distance of 127 micrometer. So this is how I placed. Press escape, then full hierarchy. Now 3 grating couplers are available. Now I wanted to connect this Y branch with one of the grating coupler, that is the middle grating coupler. So for that purpose, first I need to bring this Y branch near to the grating coupler. For that purpose, I go to New, select and bring close to this. Press escape. Now we need to snap this Y branch into the optical pin of grating coupler. For that purpose, I'm going to use the command Shift O. For that, I need to first select Y branch, hover our mouse on grating coupler, and then press Shift O. But you can see here, selection was an array. It means since we have used array of 3 grating couplers, before snap, we need to resolve it. For that, it is simple. Just say OK and try it again. Select over your mouse on grating coupler. Press Shift O, and you can see the Y branch is nicely connected or snapped to the output of this grating coupler. Now next we need a broadband diagonal coupler to create our MZI. For that, I go to here and broadband diagonal coupler. I select OK. Before that, uncheck this instance selection because I need only one grating coupler. One broadband diagonal coupler. Now, since it is horizontally oriented, so I need to just right click and change the orientation. And somewhere I put my broadband diagonal coupler here. Press escape. Now, in order to make circuit, I need to draw the path. So first go to layers, select waveguides, then click path and check that waveguide width is 0.5 micrometer. See, okay. Now I will just draw the path as a shorter arm of MZI. So you can see here, just here to this, double click. Then draw the longer arm of MZI this way. And here, double click. So these are the two arms of Zehnder Interferometer. Now, next step is I wanted to connect the two outputs. So these are the one output of MZI connected to one of the grating coupler. And next, another output. So in order to save this space, I just go for back side of this grating coupler and connecting like this. So come to double click. Now we have created path, but these paths are not connected to the various components. So you can see it is just left at some distance. Now we use SiEPIC command, that is convert your waveguide path to waveguide, that is the W. It will convert your path drawn as waveguide as well as connect also. So I click here. So it is asking which kind of configuration. So this is waveguide is a strip waveguide optimized at 1550 nanometer and waveguide width is 500 nanometer. Radius, minimum radius which we need to take care is 5 micrometer and Bezier parameter 0.20. This is as per our SiEPIC design tool as a DRC check. So say OK. Now you can see the components are now connected. So all paths have been converted into waveguide, silicon waveguide. So I press escape and our MZI has been created. So in order to just have an idea what is this delta L, first we can check. So this is the shorter arm length, that is the 57.798 micrometer. And if you click on the right or another arms of MZI, that is a 140.345 micrometer. So what is the delta? So in the SiEPIC tool, we have a nice tool to assess this value. So we select shorter arm, shift and click on the longer arm. Go to SiEPIC tool, waveguide, and click on the measure waveguide length difference. So you can see here, it will show you the difference in waveguide length is 82.547 micrometer. So in order to change this value or modify, we can use this partial uh, option to reduce or increase this size. Suppose I wanted to reduce a little bit. Press escape again. Click on shorter arm of MZI. Press shift, then click on the longer arm and try to get the waveguide length difference. Now it is 79.327 micrometer. Why we are interested to know the difference between these two arm length of MZI, because that determines the free spectral range of an MZI. Now we have designed this MZI. So in order to create or manage, I wanted to convert this design into cell. So for that purpose, I select entire photonic circuit, then go to edit. Under selection, there is an option called make cell. I convert this entire circuit into one cell, say MZI delta L about 80 micrometer. Or since we know it, so we can tell that this is 79.39 micrometer. And see, okay, and display fold hierarchy. Now you can see this circuit becomes an SL with this. Within this cell, these are the different components. So it becomes very easy to manage. Now I wanted to create a variant of this MZI so that instead of drawing entire circuit from beginning, we can bring small modification by changing just arm length. No need to draw the entire circuit. So for that purpose, I just select it, then go to edit, duplicate, shallow copy, say okay. Copy or duplicate of this cell is there or the original one. So in order to see it, I go to edit, go to selection and use this move by. So I shift the duplicate MZI by 150 micrometer in X direction. So you can see now another cell is available. But please keep into mind that this is another copy of our Y branch. So if I bring any changes, suppose I wanted to bring any changes in the second MZI, so it will automatically change in the first one also. So I wanted to make it variant of it. So for that purpose, first I select it, then rename, selection, or selection and then make cell variant. Cell variant, so you can see here. It seems cell variant is not created. So I select it, then edit, selection, make cell variant. Yeah, now cell variant is made. Then now this cell variant, if I wanted to bring any change, you can see here, because I changes the any. So same changes will come into another one also. So in order to make it unique variant, I need to rename it. Suppose I select, then rename this cell, and we can make it suppose MZI of 100 micrometer delta L. So you see, okay. So in order to work on the second MZI, which is the copy of the first one, I select, press Shift S. Now we have available this second one, and go to selection. So first is 57 and second waveguide width is 137. So we can bring the changes. Means I wanted to suppose increase this waveguide width. So I just select and put here. So now we can find out again the delta L with the help of this one. So it is 112. So my target is to bring at about 100. So through partial button, I wanted to reduce. So again, select and then 162. Right, this left hand 105 still. So this is quite tricky to can make little less 5 micrometer. Now this is shift, then this, and go to measure difference 101. Okay, suppose this is second MZI with 101 micrometer delta L. So in order to see full diagram, press Shift O so we can see. So in this tutorial, I have imported a custom Y branch, then made a Zehnder Interferometer and its variant also. So this is very essential tool to manage a complex circuit as well as draw the variant of the same design with minimal efforts. So after that, we can save this entire design as Subhash, Arya here. So this is variant 4. Say okay. So thank you for attending this short video lecture in which we have learned to copy the custom Y branch and design a MZI and its different variant. With this, thank you.